Okay, so hello. I would like to welcome you on behalf of MobiSystems and GDG Sofia for attending this session. The topic is how we built a successful cloud-scale product with GCP. I'm going to talk about different GCP products that we're using and how we built our product that is Media 365. So first things first, who am I? So my name is Borislav Pantaleev. I'm a web developer, a full-stack developer. My primary stack is PHP with MySQL. I'm doing a bit of React. I'm doing some Docker. Of course, this is what's popular nowadays. And for the last 2 years, I've been involved with GCP. And something important about me is that I'm not an AI robot that's been built to give you this talk. And you can easily tell because we have great designers and they would made me look better, right? So that's enough about me. What about you guys? How many of you are developers here? Can we have a show of hands? Okay, almost everyone. And how many of you are dealing with DevOps or any other operations? Interesting mix, okay. And something important, how many of you just had lunch and are feeling sleepy now? Oh, okay. Me also. So that's the agenda. It was not supposed to look like this, really, but I'm going to talk about AppEngine, the flexible environment. I'm going to talk about Cloud SQL. I'm going to talk about cloud storage, and I'm going to talk about BigQuery. And first thing is, what is MobiSystems, the company that I work for? It's a Bulgarian company that has its own applications. The two most famous ones are Office Suite and File Commander. They have more than 300 million installs, and they have like 100,000 new users per day. Those are just some numbers to give you an idea of what is the scale in our company. And what is Media 365 then? Well, Media 365 is the newest product by MobiSystems. The shortest description possible is that that's an e-book sharing platform, and it's like YouTube, but for e-books. Everyone can become a publisher. Everyone is a reader by default. And readers are reading for free, and publishers can earn money from their books. And how we do this? Well, we run ads between the pages. So that's, I think, enough for now. And everything started with our Android app. We had an application. The name was UB Reader, and it had more than 5 million installs. And our idea was that this application should be connected to a server. There was no server-side integration, and we wanted to do something bigger. And we wanted to make an application from which you can download books from a catalog, you can upload books, and a couple of other cool stuff. So the most important thing here is that we are not starting from zero. We already had 5 million users. And we wanted to prepare for, let's say, all of them. We also have an iOS app, which still doesn't have the full capabilities of the Android one, but it's getting there. It's one more client that is going to talk to a server, to the backend. Both the applications have web views inside them because we want to achieve greater flexibility. And by saying this, let's make a small recap. So we have around 5 million installs. Not all of them are active users, but that's still an impressive number for a project that is just getting started. And what we need is a scalable API and a scalable website. So what we decided to do in this case is we built a monolith application. I know that this is not a cool thing to say, because everyone now is doing microservices, everyone is going with serverless solutions, but I'm a web developer. I feel most comfortable in doing what I've been doing for the past 7 years, which is web applications. And so we were faced with a question, where should we host our application if we expect a lot of users to come from the very beginning? Well, one option is the cloud. So what's the cloud? Sorry, but this is obligatory slide. The cloud is just some Linux servers. Some of you may argue that it's virtual servers on Linux servers. That's fine. And there are a couple of cloud solutions. Which platform should we choose? Well, in MobiSystems, we have experience with GCP. So it was the most natural choice that we've made. We did a bit of research, of course, but we saw that everything that we need is already integrated on GCP. So our position is like, let's try with GCP and see how things go. But this doesn't answer the question, where should we host our code? Well, there are a couple of options. The main ones are the Compute Engine. Compute Engine is infrastructure as a service. This is where you put your virtual machines. And it can auto-scale, yes, but it puts a bit of load on the developers because you don't have to deal only with your code. You have to think about infrastructure, about updating your virtual machine, scaling it, and so on. And this was not the perfect use for us. We wanted something that is simpler, something that can auto-scale, and something with which we will feel more comfortable writing code, producing value, than dealing with operations. So the next option is Kubernetes Engine. Ignacy had a talk about it earlier today. Basically, Kubernetes Engine is like managed containers. It's getting more and more popular. But I think that for our project that was just getting started, that would be an overkill. And we wanted to go even simpler than that. And that's when we discovered AppEngine. AppEngine has been around for a couple of years now, maybe more than 8. And just to mention cloud functions, this is something that is getting more and more popular. This is what they call serverless, or another explanation is function as a service. With cloud functions, you can do cool stuff, but I don't think that this is the best place to host a monolith application. I don't even think that it's possible. So another thing that can help you choose a computing option on the GCP is their pricing calculator. You can put whatever resources you need, click the estimate button, and it will give you a pretty accurate estimate of how much this is going to cost you at the end of the month. And we know that the cost is something that matters. Depends who's paying the bill, but OK. And as you already know, we chose the AppEngine Flexible. This is spoiler alert. This is how our application looks right now. So we have Android and iOS applications. They both talk to the monolith web, which is happening via API, but also with web views. Some developers are against using web views in mobile applications, but so far they've been working great for us, and they provide greater flexibility. So, OK, we should put them on the monolith. We will be paying attention about splitting the monolith in microservices. There is a talk about this later. But for now, we wanted to keep things simple and follow the KISS simple. I think everyone here knows it because most of you are developers. And OK, so let's talk about the AppEngine. AppEngine has two options. The standard environment, which has been around for a lot of time. This is a popular solution for lots of small websites, lots of, let's say, people that just want to experiment with it. The cool thing about it is that it scales down to 0, which means that this is very cost-effective. Another thing about it is that it deploys really fast in a couple of seconds, or maybe up to 2 minutes. It depends on how many files you have. And something interesting about it is that it runs in a sandbox, which means that there are a lot of limitations for you. Some things you just cannot achieve with it. And we were saying, OK, this can work for us, but there was a major deal breaker. And that was the PHP version. I told you that I'm a PHP developer. So when we started a year ago, the PHP version was 5.4, I think, which is really not good enough for us. PHP 7.2 introduced a lot of benefits that we wanted to use. So that was it for us. We couldn't use the standard environment. There is now PHP 7.2 on the standard one, but it's still in beta, and you know that you shouldn't use beta in production, right? So what is the flexible environment? The flexible environment is something where you can run a lot of languages. PHP, Python, Node.js, .NET, almost anything that serves on port 80. And this is perfect because it can be extended to a really a lot. I will talk about it later. Something interesting about it is that it's like VM, which runs a Docker container, and you can SSH right onto the machine. So each of those languages have their own container that is going to be built when you deploy. For PHP and the other languages, you can find the source code on GitHub. Everything is open source, and as we know, open source is the next best thing after ice cream and pizza, right? So I suggest for everyone that wants to try Appengine, just to dive a bit deeper into the repositories, just to see how his container is going to be built, what is going to be into the container. Here I learned that my container is going to have Nginx web server, PHP, and my code inside. I saw that there are lots of configurations that I can change, and that's great because you can make pull requests to it, you can open issues, and you can see everything that's happening there. Okay, but what about the ease of deployment? We want something that it's easy to deploy and something that will save us time, so we don't have to worry about deployment. We can focus only on the code and only on what we are building. Well, it's pretty easy, actually. The only thing that you need is a YAML file. In this case, you only need 4 lines of code. And let me explain them. The first one is the runtime. If you want to use PHP, you can just specify PHP there. For Node.js, Node.js, it's obvious. And the environment is an important line because you have to specify that this is going to be hosted on the Flex environment. Another thing, of course, and the last thing that it's needed is the document root, which is pretty often the web. This is the name of the directory that is having your index file. And you can alter a lot of things with this YAML file, but this is the minimum that you need to deploy. So when you hit deploy, a couple of things happen. Sorry. First, it takes a couple of minutes. And this comes as a shock to people that have used the standard environment because the deployments of the standard environment take a couple of seconds, and now suddenly your deployment is taking 15 or more minutes. So we were wondering, okay, but why is that? What's happening here? Well, what's happening under the hood is that your code gets sent to Cloud Builder, another GCP product, which is like Docker, which is, I think it is Docker, not like Docker. It's building your code into the PHP plus Nginx application. It's pushing the image to the container registry, which underneath is using the cloud storage. And then it's deploying it without downtime. So yes, this takes a couple of minutes and you have to deal with it. When you have a successful deployment, you can go to the console and just inspect what's happening. There are a couple of options out of the box for you. For example, with Appengine, you can really easily split your application in different microservices. Usually, your application is considered as a service, which can have different versions. If I want to test something, like A/B testing, I can deploy a different version of my application, and just with a click of a button, I can do a traffic split and say, I want 20% of the traffic to go to the new version of my application, so I can see if there are some errors, and that I can fix them. And on the lowest level, you see that each version can have a couple of instances. Usually, when you deploy, each AppEngine Flex gets 2 instances. This is something important because if you want to save cost, you can say, I want 1 instance, but you cannot go below 1 instance. With the standard engine, you can go to 0 instances. But with the Flex one, you get by default 2. You can limit them to 1, and you get maximum 20. So after a successful deployment, what you can see in the console, it has great UI, by the way, is that you have an instance, you can see the start time, and you can easily SSH on the machine. Who doesn't love SSHing on his machine in production? Only me? OK. So you can do this right from your browser, which is great, because sometimes you're on the go, you're not on your machine, and if you want to debug something, you can do this right from your browser. It just takes 1 click. Another method for SSHing on the machine is if you use the gcloud app command. This is something that you have to install. It's even available for Windows, I think. And from there, once you're on the machine, you can start to inspect what's happening. I, again, recommend for everyone that is going to try this to just dive a little bit deeper. This is not needed, but this helps you understand what's happening. So once you're on the machine, you can see that there are a couple of Docker containers running. How you can see this? You just type docker ps, and you can see all of the containers that are currently running. So the first one is your application, which has PHP, it has Nginx, and your code, of course. But something interesting here is that you get another Nginx that serves as a proxy for your application. And you can change the configuration of almost all of this. There are some monitoring tools and so on. But what is even more interesting, and it's written into the documentation, and of course you can go and read instead of just trying things like me, is to SSH onto the Docker container. In this case, I'm not sure that it's called SSH, but you get access to the machine. So once we've been using Flex Engine, everything was working great, but we still weren't live. We weren't ready with our application. So we wanted to make a cool feature where, as a publisher, you can have a PDF that you want to publish as a book, and instead of selecting an image cover by yourself manually, we wanted to offer you an image cover. And how did we do that? Well, we wanted to make something like a screenshot of the first page of your PDF file and say, this can be your cover. If you want, you can change it, but why not? Some people are using the first page of PDFs as a book cover anyway, so if we make their life easier, that would be great. And there is a cool library, very famous one. The name is ImageMagick, that can open PDFs and convert the first page to an image file. ImageMagick is installed by default on the App Engine, I think, both on the standard and the flexible. You just have to enable it with a configuration file. It's really easy. But that was not enough, because to read PDF files, ImageMagick needs something called GhostScript. So, OK, we need GhostScript. How do we install GhostScript on our machine? Well, it's pretty easy, actually. You just change the runtime to custom instead of PHP. And this now means that you're going to provide a Docker file on which you can do whatever you want. In our case, we said, OK, let's start from the default flexible engine container, and let's just install GhostScript. That's it. That did the work for us. And then we can deploy this, and it will be scaled the same way that the previous image was going to be scaled. So that covered AppEngine Flex, and that explained actually why we need to customize it and why standard engine wouldn't do such a good job for us. But now let's see what about the users. We need to store them somewhere. I told you that we already had 5 million installs. Where should we put our users? Well, we need to choose a database. There is a pretty good tool, which is called Storage Options. I know that this is not really visible, so I gave you a link, where you can follow some paths and see, answer some questions and see what should I really use. In our case, it was very simple. Is our data relational? Yes. And okay, if it's relational, do we need horizontal scalability? Well, for now, not. So the most obvious choice is just use Cloud SQL. If you need horizontal scalability, there is the Cloud Spanner, but it's something that is, I think, really expensive, and if you need it, good for you, but we are still not there. And what is Cloud SQL? This is the fully managed PostgreSQL and MySQL. It has great availability, more than 99%, and it can scale vertically really a lot. Like, if you need those kind of resources, this means that you're either doing something great or you're doing something completely wrong, but that doesn't matter because it's on the cloud and you don't worry about it, right? And Cloud SQL can have a couple of configuration options. You can assign a public IP to it. You can configure how the backups are going to be made. You can configure what machine is going to be used for the Cloud SQL. And you can connect to Cloud SQL from almost anywhere. My favorite thing about Cloud SQL is the backups. I don't know who is the author of this joke, but most of you have seen it, that dropping a database in production can wake you up a lot better than coffee. So about the backups, they're done automatically each day, and you can restore a backup with a click of a button. What's better than this? You're a developer, you're producing code, you're building an application. You don't have to worry about databases, backups, and so on. And how can you connect to a database just to inspect it or just to see what's happening there? Well, this is one of the options. You can use the Cloud SQL Proxy, which is another command line, and this gives you access from your host machine on TCP. You can also connect by Unix socket, but this is what I'm doing really often. And that's it. I can say, of course, more about Cloud SQL, but I just want to cover more things that we're using. So our application is about ebooks. Where should we put all of these ebook files? PDFs, EPUBs. Where should we store the profile images, the image covers? Well, I think the best solution for us is cloud storage. Cloud storage is something like infinite FTP, where you can just put lots of files and let Google worry about it. It has really great durability, 99 point something, maybe someone's finger stuck in there. It's cheap, and it's something that can store your files for you without you having to worry about it. Something interesting about cloud storage is that it has different options. Again, another decision that you have to make. Some of them are for doing backups or storing backups, but other, like the regional and the multi-regional cloud storages, are for web applications like ours. One of them is more expensive than the other because it has geo redundancy and end user latency is really lower. But you can use a mix of them, and what's interesting is that if you're using App Engine, as we are, you get 5 gigabytes of free storage. And that's great. Who doesn't love free things? But how do you know how much storage you're using in your bucket? Well, there might be another way, but I'm again using something called gsutil, which is another command line from the GCP SDK, with which I can find the bucket size really easily. If you're familiar with Unix systems, this would make sense. And I know that a lot of people are using other storage providers. Maybe Amazon S3 is really popular. And the good thing with cloud storage is that you can migrate to cloud storage without changing a single line of code. I think this is one of the best things about it, because you can just test it, see how it goes for you, and then use it constantly. I don't know. OK, so now a bit about BigQuery. We want to do a bit of analytics. So where we should put all of this analytics data? Well, Cloud SQL is not the best solution for it because we have lots of analytics that we want to analyze, and we want to store them somewhere safely. And BigQuery is exactly a solution like this. It's a data warehouse, fully managed. You can put lots and lots of data and it will scale for you. And the best thing is about it is that you can run SQL-like queries. What's better than that? I mean, I didn't know about the existence of such product until I did a bit of research, and I was more than happy to discover that BigQuery is really cheap and is doing its job perfectly. But how do we use it? Well, from developers' point of view, we just put data inside and never worry about it. But our management team is using another GCP product, which is called Data Studio, that can connect both to BigQuery, it can connect to Cloud SQL, it can connect to NoSQLs, and by doing this, they can make and analyze, they can make reports, they can analyze data, and they save us lots of time in which otherwise the developers had to make some reports. The product management's been very happy with this tool, and you can see that they've made a very important business report with it, and I didn't even know about it. One of our managers sent it to me. Okay, so the most important question is, I don't know how many of you have seen the YouTube channel of We with Blend. It was really popular some years ago. For us, the question was, We with Blend? No, we with Scale, of course. Because we're building a cloud-native solution, which means that everything is on the cloud, and we need it to scale so it can handle all of the users, and we don't know how much of those users we are going to get in the beginning. So we couldn't predict that, and we actually didn't. We let Google worry about this. And how does the automatic scaling work? Well, automatic scaling is really simple from developer's point of view. There is just something that is monitoring your average CPU load, and by default, if the average CPU load is above 50%, you will get a new instance. That's it, simple as that. Of course, you can do some more custom configuration. You can say what's the minimum number of running instances that you want to get. The default is 2, you can limit it to 1. And that's it. You get automatic scaling. Your website will handle all of the load that is supposed to come. And OK, that's about automatic scaling. But what about availability? Well, there is something called health checks. Health checks are the thing that Google is doing to make sure your machine is up and running. And there you have 2 different types of health checks. The first one is the liveness check. Liveness check means that something is going to monitor your virtual machine and the Docker container running inside, just to make sure that everything is up and running. And if it's not, your virtual machine is going to be restarted. Readiness checks means that something will check if your application is answering with HTTP status 200, and it's ready to serve requests. If it's not, it will be taken out of the load balancer. So those are 2 different things that you can, don't worry about them, or you can just configure them and specify at which path the check is going to be and what will be the interval. For example, we didn't even touch this. At one point, we thought we should. But this is just nice that you have the option to configure if needed. And everything was working great. Everything was perfect until one day, when we opened our web application, we were live. We saw 502 error, server error. Please try again in 30 seconds. Well, we tried for a lot more than 30 seconds, and we were not live. So now was the time to panic. Some of us thought about quitting their jobs, but that didn't happen, fortunately, because we could recover really easily. Let's see actually how we solved our problem. We went to the logging. There is something called Stackdriver logging. It's really cool feature. All of your logs can go there, and you can analyze them. And we saw something there that was complaining about the maximum processes being started or whatever. I felt uncomfortable looking at this because our general idea was, OK, focus on the code, focus on the product. Don't deal with infrastructure. Don't deal with problems like this one. But nothing is magic. Nothing really is working without any problems in the real world. So let's see what this means. Well, where you can see it, I told you in the beginning that there is the PHP Docker container configuration files in the GitHub repository. So there you can inspect what are the default settings. For example, PHP FPM is the process manager for PHP, and you can see that there is something that is limiting the maximum of children being spawned. This really didn't make much sense for me. I was thinking, should I increase this number? Should I decrease it? What should I really do? But one thought that I had was, maybe there are so many processes being started at the same time, let's say we have a traffic spike, that the PHP FPM is starting a lot of processes, and there is just not enough memory for them. So how can you check this? Well, it might sound obvious, but when you are having a panic attack about your website not working, it's not really like that. You can go to the dashboard of AppEngine, and there you can select the memory usage. We saw that we were getting near the limit memory usage. So yeah, this confirms the theory that maybe there was so much memory used that our machine was dying. Even before it had the chance to auto-scale, it was just dying. And what we can do in this case, well, you can increase the memory, of course. Again, the YAML file, you don't have to call it up. You can name it whatever you want, .yaml. And inside, you can specify how much RAM your machine is going to have. The default is 0.6, which is not a lot, especially if you're having real usage. And there is a formula with which you can calculate how much RAM you need. The formula is that you should multiply the number of CPUs, by default you get 1, by a value between 0.9 and 6.5, and subtract the RAM needed for the overhead of the virtual machine, which is 0.4. So we increased the RAM to 1.6, and that was it. We again had a scalable product that's been running flawlessly ever since. And this example is something that really proves that, okay, it will auto-scale, everything will work, but you still need to do some work. Nothing is really going to be magically working for you if you don't pay attention to it. And that's it. We had cloud solution. We had a monolith application that scales. We had a database that scales vertically. We have a storage that also scales. We have BigQuery for analytics. And we have a solution that is born and raised on the cloud. And since then, everything's been working perfectly. But the point is that you should experiment with that. We should experiment and try to break things and then fix them before you get problems like we did. By the way, Google has great support. We have contacted them for a couple of issues. And this is also important when you're choosing a cloud solution platform. And that's it. If you have any questions, I'll be more than happy to answer them.
Hey, thanks for the presentation. We do have a couple of questions. Can we switch to them? Actually, the first two, you're going to handle them just in a little while. First, I'm going to answer to them. Thank you for those questions. Now you're showing what a community is not. Like what way you shouldn't put your words in so that you really rather stay aside and try to survive by your own. So if you want to be part of community, please be inclusive. So, and actually, I'm pretty sure that Borislav is going to handle the questions easily. Obviously,
yeah, I can start just.
He's having the mic, so he has the power now. You don't get to be the one dictating the things here. But actually, if you want to get an answer like, I don't know PHP, should I use it? Put it that way, not the other way, you know. So now get to the two cool
Okay, so the first question is if PHP has any future than maintaining bad code. Yes, PHP has great future, and I really believe in it, especially with the new versions, 7.2, and I think 7.3 is going to be released soon. And it has lots of cool things, and the performance has been increasing. And yes, PHP has its bad sides. But at the end of the day, do we have a running application that scales and was built really fast? Yes. So why shouldn't we use PHP?
But
and
because you're embarrassed, don't you feel embarrassed?
No, I'm not embarrassed. I think this is the default joke that everyone is saying when you say PHP and so on. So the next question is, do you feel embarrassed? Whatever. I answered this. No. BigQuery is really powerful tool for analytics. Why not using it along Firebase Analytics? Yes, we're using Firebase Analytics, but Firebase Analytics and Crashlytics, as far as I know, are used in the Android app. And in the website, we have other analytics that we want to track, and for them, we are using BigQuery. I hope that answered the question.
If it doesn't, please do add additional questions in a positive manner and inclusive manner. Thank you. If you were to start from the beginning, would you go for microservices or instead of...
Yeah, this is a really good question. Thank you for it. No, I wouldn't do this. And the reason for that is I don't believe in the hype-driven development. I don't think that you should use something that you don't feel comfortable with. Yes, you can play it, you can experiment with it, and when the need arises, you should use it. But why should you use it from the very beginning when you're not knowing how your application is going to develop? Is it going to be a successful one? Is it going to even work? You need to build fast, and you should build with whatever you feel comfortable with.
Thanks. Do you run some cleanup to remove stale files from cloud storage?
Not really, because we have lots of stale files on our development environment, and we are not anywhere near the 5 gigabytes limit, so there is no need for that.
Okay, thanks. Now we can see a lot of persistence into how do you scale a PHP application?
I think you can ask Facebook about this. They have still lots of PHP as far as I know.
We don't have Facebookers today. Maybe we'll have to invite them for the next one.
Yeah, okay, but the point is that it scales, believe me. You don't have to use the latest thing to scale. I mean, you can use Node.js for some things, but you need the right tool for the right problem. That's my belief.
Sure. Did you hit a query concurrency rate limit?
Not really, because we've been just putting data inside, and as it's a data warehouse, you can put lots of data inside, and they charge more once you start to query this data and analyze it.
Okay. The last one that's still here, but many more can be added. Is Firebase a good alternative for an app like yours?
We were considering to use Firebase Auth for storing our users, but it had some limitations that stopped us from doing so. Otherwise, it seemed like a great product. And we are using some Firebase features like the dynamic links and so on, but we cannot use Firebase for everything, especially on the server side.
Why?
Because it's meant for front-end developers mostly, I think, and I'm more of a back-end developer, and I like to have control of everything.
Okay.
If that's it.
I don't have any further questions written here. People are having some struggles to put them in a more positive way.
Yeah, okay.
So if no further questions here,
something for PHP, yeah, this is versus assembler. Maybe you can do your application on assembler too, if that's your thing. Nobody's going to judge you. So whatever you feel comfortable in and whatever works for you.
Yeah, thanks for the very constructive questions. And thank you for the presentation, Borislav.